Okay, good morning everyone. So today we will start our third module, and this will be the biggest module. And after this, in three lectures, our syllabus will be over. So, and this is also the most difficult one. So we'll start with the scratch, starting from your diploma, what you have done. I will revise everything, and then we will start the actual engineering syllabus. So first, we will see the vector algebra. Is not the part of engineering. Let me just clear this. So what is a vector, first of all? Anyone, what is a vector? What is a vector, Raj?
Which has both magnitude and
So
direction.
it has both magnitude and so the quantity which has magnitude and direction. So for example, when you talk about the displacement, talk about velocity, and so on. A scalar is something which just has a magnitude and not the direction. Okay, fine. So I'll give you can if I will give you an example. Say a bar is equal to 2i plus 3j plus 4k cap. What is the direction? Shantanu, can you tell me what is the direction for this? So I've written a vector now, and a vector is something which has a magnitude as well as direction. So I have written something, Harsh. Yes. What is the direction? Fine. So direction is there, but it is in terms of the position vector. So for a vector, where we will have some initial point. So a vector, I can always draw it like this. So A to B. So this is the direction A, B. So for any vector, it will have an initial point, and there will be a final point, or which is also called the terminal point. And if I want the magnitude of a vector A bar, so a vector is actually a directed line, and from a point A to B, this vector will be AB bar. Okay, so from the diagram, we have written it like this. So magnitude is given by magnitude of the vector is given by modulus of A B bar. So scale of the vector is initial point and it is final point. So considering that you have some knowledge of the vectors, With this ongoing things, I will also give you the final formulas which will be used in the example. Say, if AB bar is xi cap y j cap plus z k cap, then mod of AB bar, the magnitude of the vector is given by anyone? Do you know how to find out magnitude of a vector? Dharmik? Yash, where is Yash? Yash Sharma? Yash Shah.
Yes, sir.
Well, can you tell me the magnitude? What is the formula to find out the magnitude of this vector?
सर याद नहीं आ रहा सर इसे.
Okay. Janvi Mohite.
Sir, under root x1 plus yj plus zk.
No, no, no one. Fine. So remember these things. This we are going to need a lot of times. Under root x square plus y square plus z square. So when you take mod of a vector, so it is under root x square plus y square plus z square. This also graphically represents length of the vector AB bar. So direction of this vector is starting from A and ending at B. The starting point is called the initial point. The final point is called the terminal point or final point as it is. Okay. So remember this formula. I want you right now to make a take a blank page, register page, and wherever I make a square, you start writing those formulas there. So if AB bar is this, then mod of AB bar is given by under root of x square plus y square plus z square. Fine. I'll go to the next page. The new definition. Position vector. So what do we mean by a position vector? A point, capital A, in space can be associated with a vector. Can be associated with a vector. With as initial point, origin, and final point or the terminal point. Let me use the word terminal. The terminal point as A. So how will we denote this vector? The vector is starting from the origin. We'll call it O, and it is ending at the point A. So the vector OA bar. OA bar. So whenever I use this kind of notation OA bar, it means that the vector is starting from origin, ending at A. It is denoted by OA bar, and the other notation is A bar. So look, for any point I can write the position vector as A bar. So if A is the point, small a bar, if B is the point, small b bar, and these are the position vectors. So just for your understanding, I'll write down for an example, if 1, 2, 3 is a point in space. So in three-dimensional space, 1, 2, 3 is there. So the position vector of A 1, 2, 3 is O A bar, which is also denoted by A bar, and which is 1 into I plus 2 into J plus 3 into K. So this is the position vector A bar. So I can do this for any point. Whenever I am giving you a point, you can consider it as a vector which is starting from origin and ending at a point. Fine.
Yes, sir.
Equality of vectors. So I'll say that two vectors are equal if magnitude and direction are same. Then vectors are said to be equal. So I'll just, in a two-dimensional plane, you have x-axis, you have y-axis. I'll make one vector over here. I'll take A, I'll take B. I'll take here C and D. So I have vector AB bar and CD bar. Are the direction of these two vectors same? Yes. So both of them have the same slope and they are like this. So both of them have the same direction since those are parallel lines. Also their magnitude is same, and in such type of cases what I say is this vector AB bar and CD bar are equal. So what operations I can do on vectors? Okay, so operations, first one, vector addition. Vector, I won't go into the details of what you have done in the previous classes. I'll simply take two vectors and I'll tell you how to add them. That's it. Don't get into those triangle law, parallelogram law, and everything. What we are going to do here, that is what is required. That's all we will see right now. So if I have a vector, say A bar as I plus J plus K. This is my first vector, and B bar is given as minus I plus 2J minus 3K, and A bar plus B bar is equal to, okay, someone who haven't spoke any time till now, And unmute and you can tell me the addition. Sai Patil, no. Prajwal, Wag.
No idea, sir.
Prajwal Wag, you cannot add this to A bar and B bar. Shreyas Palande, can you speak? Shaunak is here. Shaunak, can you add these two vectors?
It is 3J bar minus 4K bar minus 2K bar.
3 J bar minus 2K bar.
Hmm.
So it is just, okay, yes, it is correct. I plus J plus K. This vector is to be added to minus I plus 2J minus 3K. Okay, and collect the coefficients of I minus I will get cancelled out. J plus 2J, which will become 3J. K minus 3K, which is minus 2K bar. This is how we add the vectors. There are another laws, but they are used for different purpose. Right now, what we are going to need is this kind of addition and subtraction. Addition, vector addition and subtraction. So what you are doing is you are simply collecting the coefficients of I and J and you are doing the operation. That's it. Okay. Now multiplication. So there are different types of multiplication in the vectors. So we will see all of them. So if I want to first of all multiply, or what you can say a scalar multiplication by a scalar. What do we mean by scalar? It is just a simple number that you have studied till now. Okay, say k is a constant, is constant, and a bar is equal to x I cap plus y j cap plus z k cap, then k into a bar is equal to k times x I cap plus k times y j cap plus k times z k cap. So how do we multiply by a number or the constant? What we do is we multiply that constant to each and every coefficient. That is multiplication by scalar. Okay. Now we'll see multi or the product of the vectors. So there are different types of product of vectors. Again, this is very important. Product of vectors. So the first type of product, which is scalar product, which is also called dot product. So if A bar and B bar are two vectors inclined at an angle theta, then the scalar product is defined as mod of a bar mod of b bar into cos of theta, and is defined as denoted as and is denoted as a bar dot b bar. This is the theoretical definition. Okay, so I have a vector a bar, multiplying it to a vector b bar, and it is given by mod of a bar mod of b bar into cos of theta. Mod of a bar, in complete chapter, I'll be using this way of notation. So if there is bar, it is a vector. If I write a, it means that it is the modulus of the vector a bar. So you can see that what is the answer? Answer is not a vector, it is a constant number. This is constant. In this terms, it is scalar. So answer scalar aa raha hai, that's why it is called the scalar product or the dot product. Now this is the definition, theoretic definition how you multiply two vectors, but how we are going to multiply in this chapter. So if a bar is equal to x1i plus y1j plus z1k, and I'm writing another vector b bar is equal to x2i plus y2j plus z2k. So the dot product a bar dot b bar will be given by. So when I want to multiply this two, how I am going to multiply? I will multiply I term to I term, j to j, and k to k. So x1, x2 plus y1, y2 plus z1, z2. Add this in your list. This is called,
Sir, you have not written then I and J, I, J, K.
no. So this is the way, I mean, I'll tell you why it turns out to be this. So this is the dot product.
Sir, and where is cos theta?
I'll explain you just a minute. So when I'm doing dot product of this vectors a bar and b bar, it turns out to be this. Okay. Now to explain where is this I and j gone. What is I? If anyone can tell me. In three-dimensional space, you have x-axis, y-axis, z-axis. So I is a unit vector in direction of x-axis. This is your I. Unit vector in direction of x-axis. This is your j. Unit vector in direction of y-axis. And you have this k cap as unit vector in direction of z-axis. So Dhruv, can you tell me angle between I and j?
90,
90. J and k?
90.
90. So
90.
all of them have 90 degree. So if I go by this definition, the previous one, if I do I cap dot j cap. So as I said, it is a unit vector. So modulus 1 आ जाएगा into cos of angle between them. The angle between them is 90. So cos 90 is 0. तो I को जब तुम j से मल्टीप्लाई करते हो तो आंसर 0 आता है. Similarly, if I multiply j to k, answer will turn out to be 0. Only if I is multiplied to I. I into I, that will be 1 into 1 into cos of 0. Cos 0 is 1. So only when I is multiplied to I, answer is 1. So how do you get this formula now? Now we'll multiply these two things as we multiply a bracket. Have you written this in your list? Please write it down. Later I will tell you the proof of this.
Yes, sir. Done.
So we have seen that the I is multiplied to j, then the answer is 0. When j is multiplied to k is 0, I is multiplied to k, answer is 0. So what I want to multiply here, x1 I, y1 j plus z1 k. This is to be multiplied to x2 I, y2 j, z2 k. So how we multiply two brackets? This x1 I will be multiplied to x2 I, y2 j plus z2 k, plus y1 j will be multiplied to x2 I, y2 j plus z2 k, and z2k will be multiplied to x2, z1k will be multiplied to x2I, y2j plus z2k. Now multiply this I to all three of them. So I into j will become 0 when this will be multiplied to this. Yes. When this I will be multiplied to this k, answer will turn out to be 0. Am I right? Yes or no?
Yes.
Yes. So बाकी दो टर्म जीरो आंसर देने वाले हैं. When I multiply this to the first one, I will have x1 into x2 I into I. What was I into I? 1. Just now we have seen that mod of I into I into cos of 0. So what we have is mod of I is 1, cos of 0 is 1, so this will be 1 plus. Now this j will be multiplied to I in the first one and to the k in the third one. So दोनों 0 हो गए. When it will be multiplied to itself, we'll have y1 y2 plus z1 z2. Clear? So this is how we take the dot product of the two vectors. Any problem?
No, sir.
So don't remember this AB cos theta and this. What you have to remember is when you have to take dot product, what you are going to do? You are going to multiply the coefficient of I to the coefficient of I. Will multiply coefficient of j to coefficient of j, coefficient of z to k to k. That's it. Now the next type of product, that is second, is cross product. Vector product, vector product, or the cross product. The vector product of A bar and B bar is denoted by A bar cross B bar and is defined as A bar cross B bar is equal to mod of A bar mod of B bar into sine of theta into n cap, where n cap is a unit vector perpendicular to A bar and B bar. So if I want to multiply two vectors, I have a vector A bar, I have a vector B bar, and I want to find the cross product. Look, this is the cross product. So what you're doing, A bar, B bar, modulus, both of them. So it becomes constant. Sine theta is again a constant. And this constant is multiplied to a vector n cap. So you can see that resultant will be a vector. So when you take a cross product, your answer is a vector. So this product is called the vector product because your answer is going to be a vector. And this can also be written as A, B sine theta into n cap. So what you are doing, you multiply the module and you have the third vector which is perpendicular to this A bar and B bar. So that is multiplied to AB sine theta. Now this is the basic definition. So again the question arises when you have A bar as x1i y1j cap plus z1 k cap, and B bar is equal to x2i plus y2j plus z2 k cap. Then A bar cross B bar will be given by I j k x1 y1 z1 x2 y2 z2. Again, I'm making a square added to your list of formulas. How do you multiply two vectors? I mean, how do you take the cross product of two vectors is like this. Now again, well, I'm not going to do this in detail now. But again, it is the same idea. For that, you will have to see what is I cross J. If you take I cross J, how you are going to get the answer for this? Modulus of I by our previous definition, modulus of J, sine of angle between them, which is 90. Can you tell me a vector which is perpendicular to I and J?
K.
K. So modulus of I is 1, modulus of J is 1, sine 90 is 1. So I cross J क्या आ रहा है? K, right? Similarly, J cross K क्या आएगा? Modulus of J, modulus of K, sine 90 into what will be n cap in this case? I J को perpendicular कौन है? Sorry, J cross K को perpendicular vector I. Okay. So in this manner, you just multiply these two things. Now we'll see what happens when I is multiplied to I. So modulus of I, sine of angle between them, it is 0. and a vector perpendicular to both of them. I can take j or k, whatever. But sign 0 is 0. So I cross I is 0 in this case. Am I clear to everyone? If you have any difficulty, ask right now. Done? Should I go ahead? If there is a silence, I will think that yes, everything is clear and I will go ahead.
Yes, sir.
Yes, sir.
Fine. So add this to your list. How do you take the cross product of two vectors? Uh, Dot product, cross product, this we are going to need from time to time. Next. Scalar, triple product, or it is also called as the box product. The product is defined for three vectors a bar, b bar, and c bar as a bar cross b bar dot c bar. Which can also be written as is also given as a bar, b bar, c bar. So a bar cross b bar dot c bar is also equal to a bar dot b bar cross c bar. And this is written as a bar, b bar, c bar. Now, how can I find it for three vectors? Now, if a bar is equal to x1 I plus y1 j plus z1 k, b bar is equal to x2 I y2 j plus z2 k, c bar is equal to x3 I y3 j plus z3 k. So a bar dot b bar cross c bar is equal to a bar b bar c bar. This is given by determinant x1 y1 z1, x2 y2 z2, x3 y3 z3. And so proof of this you can tell me now if anyone can guess. How we get this determinant? No one? You know actually what is B bar cross C bar. What will be B bar cross C bar? I, J, K, X2, Y2, Z2, X3, Y3, Z3. And this you are taking dot product with X1I, Y1J plus Z1K. So this I will be multiplied to I, and that will make the first entry as X1, second entry as Y1, third entry as Z1, X2, Y2, Z2. Anyway, if you if it is difficult to understand, just try to remember it. Again, new formula for your list. Done.
Yes, sir.
Now just some remarks. Wherever required, we will use it. Vector triple product. A bar cross B bar cross C bar is equal to A bar dot C bar to B bar minus A bar dot B bar into C bar. The answer will be scalar or it will be a vector. Can anyone guess? We won't go into
Vector.
the. It will be a vector. Why?
Because we are subtracting with the
But what's the guarantee that this is a vector? That can be subtraction of two scalars also.
There is no constant.
So what? Yes.
Yes, sir.
Can you tell me it is a scalar or it is a vector?
Sir, it is a vector
Why?
because their cross cross multi cross product. It is a cross product. So
So cross product of three vectors it is. It is not of two vectors. So from the formula, can you tell me a reason why you can say that yes 100% it is a vector or yes 100% it is a scale. Either use the left hand side or you use the right hand side, make some conclusion and tell me why it is a vector or it is a scalar.
So, box product is only used for vectors, three vectors, and it is
So
not used for scalars. So it is definitely vector.
okay, so if you look at the left hand side, this term is a vector. B bar cross C bar is a vector. Then you have this A bar as a vector. Then again you are taking cross product of these two vectors. So the final answer will turn out to be vector. Okay. If you look at the right hand side, A bar dot B bar, this is a scalar. Scalar is multiplied to this vector B bar. So total, this will be a scalar multiplication and it is a vector. Subtraction again on the most right term, A bar dot B bar will become a scalar that is multiplied to a vector. This is totally a vector. So subtraction of two vectors is a vector. So when you take scalar triple product, the answer will be a vector. Again, this formula you will have to memorize. I'm not going to go into the details of this proof. It will be required very less number of times, 1 or 2 times maybe, but you should know this. Next, unit vector in direction of A bar is equal to x1i y1j plus z1k is given by anyone. Do you know this? A bar upon modulus of A bar, and it is denoted by A cap. So whenever there is a cap, it means that it is a unit vector. And if I want a unit vector for a given vector A bar, how can I do that? A cap is equal to A bar, and I have to divide it by modulus of A bar. So this will be x1i y1j plus z1k. What will be the denominator term? Anyone? What will be the denominator?
X1, Y1, Z1.
x1 plus y1 plus z1.
X1.
Both of them are wrong. Anyone else? Yes.
Sir, x square plus y square plus z square root.
Very good. So it is under root of x1 square plus y1 square plus z1 square. So this is the way how I can find out the unit vector or convert a given vector to a unit vector. Third one, angle between two vectors. Okay, I'll write it down on the next page. angle between two vectors. A bar is equal to x1I y1j plus z1k, and B bar is equal to x2I plus y2j plus z2k is given by cos of theta is equal to A bar dot B bar upon modulus of A into modulus of B. Yes, what will be the numerator? Anyone? Every
AB sin theta and
what are you saying? यार ना concentration नहीं है, इसका मतलब ये है. शांतनु,
Sir, no idea.
नो आइडिया. मैं 1 घंटे से वही पढ़ा रहा हूँ, मतलब सब कुछ पढ़ाया है तो
Sir, can I?
हाँ.
Sir,
तरुण,
Sir,
mod of
x1,
A bar.
x2,
wait. तरुण, tell me.
x1, x2 plus y1, y2 plus z1, z2.
x1 x2 plus y1 y2 plus z1 z2. Very good. Upon Advait Joshi, can you tell me? Absent.
No, sir, don't know.
Don't know. Who can tell? Vishal Todkar, can you tell me?
Don't know, sir.
Don't know. Fine. No one is able to tell this. That is under root x1 square y1 square plus z1 square under root x2 square plus y2 square plus z2 square. Okay, so that's it for today. This is all about the basic things of vectors. In tomorrow's lecture, we'll start with vector differentiation, and later we'll do the vector integrations. And if it is the case like today, where I'm calling people and they are not responding, I will cut your marks when I will have to give internals. I'm telling you. And whoever are answering, they will surely get the credit, because I am a person who can remember the name and what was the performance. So you can inform your friends too. Okay, I'll stop here. Thank you, everyone.
Thank you, sir.
Thank you, sir.